Today we're going to be talking about partial fraction decomposition. And what that is, it's the opposite or going backwards from when we simplified rational expressions by adding and subtracting. So we're not going to solve these two rational expressions. We're not going to simplify them. But if we were to solve those, this would equal x plus 7 over x minus 3 times x plus 2. And then the second one would equal negative 5x minus 6 over x plus 2 quantity squared. And we'd have to go and get common denominators and then combine like terms. But what we're going to do now is I'm going to give you the result, and we have to go backwards and see what our fractions are. Like what did we start with? And when we do that, we're going to be working with multiplying by the least common denominator on both sides. So we've got to make sure we factor the denominators correctly. So here are the steps for partial fraction decomposition. First, you must make sure that the function is not improper. An improper fraction means the degree of the numerator is greater than the denominator. If that is true, you must use long division first, and then you use partial fraction decomposition only on the remainder. So not many of them are going to be like that, but I'll point it out when we do. Then we'll factor the denominator completely, and then rewrite each linear factor as a sum of a constant over factors in the form a over px plus q. And then for each quadratic factor, so like if we have an x squared plus 1 factor in the denominator, we write that as bx plus c over that denominator. And then we multiply both sides by the least common denominator to get rid of all the fractions. And then we can set up a system to solve for the coefficients or substitute convenient values. Or substitute convenient values. So let's look at an example, and in this example I've done some of the steps for us already because this can be a confusing process at first. Example 1, we have x plus 7 over x squared minus x minus 6. So we don't have to worry about long division because the degree in the denominator is bigger than the degree in the numerator. So we factor the denominator completely. X squared minus x minus 6 factors to x minus 3 times x plus 2. And then we're going to rewrite it as a over the first factor, x minus 3, plus b over the second factor, x plus 2. So then what we'll do is we're going to rewrite this as x plus 7 over x minus 3 times x plus 2, which equals a over x minus 3 plus b over x plus 2. So we're going to multiply everything by the least common denominator, which is that factored x minus 3 times x plus 2. Now, when we distribute that in to each one of these, what happens is that all our denominators go away. So if we multiply that to this left side, x plus 7 over that denominator, well, we have this on top, this on bottom, they're going to cancel. So that's going to leave us with x plus 7 equals, well, then when we distribute it to the a over x minus 3, we'll have an x minus 3 on the bottom and an x minus 3 on top. Those will cancel, so we'll be left with a times x plus 2 plus, and then when we distribute it to the b, when we distribute it to the b, we'll have the x plus 2 on top cancel with the x plus 2 on the bottom. So we'll just be left with b times x minus 3. Okay, so now from this point, we have a couple of options. We can substitute a value in for x, and then that will allow us to get b or a, depending on what value we can plug in, or we can distribute and set up a system of equations. I am more of a fan of substituting in a value. So what we'll do is say, okay, what if x is equal to negative 2? So if x is equal to negative 2, that's going to be negative 2 plus 7 equals a times negative 2 plus 2, which is going to end up equaling 0, but we'll deal with that in a minute, plus b times negative 2 minus 3. Okay, so the left side, negative 2 plus 7 is 5 equals, well, negative 2 plus 2 is 0 times a is 0, so we have no a. And then we have b times negative 5. Negative 2 minus 3 is negative 5. Divide both sides by negative 5. Negative 1 is equal to b. So b is equal to negative 1. Now we're going to do the same thing to solve for a. And to solve for a, we'll make x equal positive 3. Because if we make x equal positive 3, then the b times x minus 3 factor will equal 0. So we have 3 plus 7 equals a times 3 plus 2 plus b times 3 minus 3. So we have 10 equals 5a plus, well, 3 minus 3 is 0, so 0 times b is 0. So 10 equals 5a. Divide both sides by 5. A is equal to 2. So then we can rewrite this as, up here we had a over x minus 3 plus b over x plus 2. We have our a and b values now. So our answer is going to be 2 over x minus 3 minus 1 over x plus 2. Now you could make it plus negative 1 because our b value is negative 1, or you can make it a subtraction sign. So these are the two fractions that if we were to add these two fractions together, it would give me x plus 7 over x squared minus x minus 6. All right, example 2. We have negative 5x minus 3 over x squared minus 9. So we're going to make this first factor the denominator, x minus 3 times x plus 3. Now we can break this up into our two separate fractions. So a over x minus 3 plus b over x plus 3. Then I'm going to multiply, this whole thing, by the least common denominator, x minus 3 times x plus 3. And like we talked about in the previous page, when I multiply this by each fraction, we're going to get rid of the denominators. So those would cancel, and we'd be left with negative 5x minus 3 equals, well, from the a over x minus 3 term, we would be left with a times x plus 3 plus b times x minus 3. Because again, when I multiply to the a one, those will cancel out, and when I multiply to the b one, those will cancel out. So let's have x equals -3. So that will give us -5 times -3 minus 3 equals a times -3 plus 3 plus b times -3 minus 3. The left side will be -5 times -3 is +15, minus 3 is 12, equals, this part right here is going to equal 0 because -3 plus 3 is 0. And then we have -3 times -3 minus 3, which is -6. So -6b. Divide both sides by -6. b is equal to -2. Now let's substitute in or plug in x equals +3. X equals +3 is going to give us -5 times 3 minus 3 equals a times 3 plus 3 plus b times 3 minus 3. This is going to equal 0. So we have -18, because -5 times 3 is -15, minus 3 is -18, equals 6a. Divide both sides by 6, and we get -3 is equal to a. So now we can replace a and b with the values we have. Now, you might be wondering, why did I put x minus 3 under the a and x plus 3 underneath the b? It doesn't matter what you do. Like, you could choose whichever one you want. If you switch them, your a and b value will be different than the ones that I got, but in the end, your equation, or your two fractions that we're combining, will be the same. All right, so we have -3 over x minus 3 minus 2 over x plus 3. Or again, we can do plus, negative. It doesn't matter. So this fraction here, if we were to add that, we would get the original -5x minus 3 over x squared minus 9. All right, then letter B. Letter B is different because the degree in the numerator is 3 and the degree in the denominator is 2. So what we have to do is use long division for this. So with long division, it's going to be x squared plus 2x plus 0 divided by 4x to the third plus 9x squared minus 2x plus 6. And then we're going to do long division. Okay, x squared goes into 4x to the third 4x times. So 4x times x squared is 4x to the third. 4x times 2x is 8x squared. And then 4x times 0 is 0x. Subtract. That gives us 9x squared minus 8x squared is x squared minus 2x plus 6. Well, x squared goes into x one time. So we have x squared plus 2x plus 0. And then we subtract, and we get -4x plus 6. So what we get here is 4x plus 1 plus negative 4x plus 6 over x squared plus 2x. We don't want to forget this in our answer. Must be in final answer. But then we're going to do partial fraction decomposition to this. So we'll do that over here. So negative 4x plus 6, but if we factor the denominator, we get x times x plus 2. And then that means it's got to be some number over x plus some number b over x plus 2. All right, so then we're going to multiply both sides by x times x plus 2. So on the left side gets erased, the denominator gets erased. So if you're doing this correctly, the denominator on the left side will always cancel out. So now we multiply it to the a over x. The x's will cancel, so we'll have a times x plus 2. And then we just to read it to the b term, plus b times x. So then we will evaluate it at convenient numbers. Let's do x equals negative 2, because that will give us a 0 for next to a. So x equals negative 2. That will give us negative 4 times negative 2 plus 6 equals a times negative 2 plus 2 plus bx. So the left side, negative 4 times negative 2 is positive 8 plus 6 is 14. Oh, wait, x is negative 2. I'm sorry, x is negative 2, so b times negative 2 equals negative 2b, because this is 0. Divide both sides by negative 2, so negative 7 is equal to b. Now let's evaluate it at x equals 0. So x equals 0, so we get negative 4 times 0 plus 6 equals a times 0 plus 2 plus b times 0. The left side is just going to be 6 equals 2a, and then this part is 0. So 6 is just equal to 2a, so a is equal to 3. So when we write our final answer, we need to remember that 4x plus 1 from our long division over here, 4x plus 1. So 4x plus 1 plus our two fractions here with the appropriate a and b values substituted in. So it's going to be 3 over x plus negative 7 over x plus 2. So yeah, when we have an improper fraction, so that means, again, the degree is larger in the numerator than denominator, then we have to do long division and then do partial fraction decomposition just on the remainder. All right, now let's go to the next page and talk about repeated linear factors. So if we have repeated linear factors like an x minus 2 quantity squared, then we have to have a separate fraction for each power. So an x minus 2 and then an x minus 2 squared will need to be present. We're still going to do all the same steps that we've been doing, but with these, picking a convenient value for x isn't always possible. So in example 3, we have the degree in the numerator smaller than the denominator, so we do not have to use long division. So I'm going to factor that denominator first, and then that would factor into x squared plus, x times x plus 1 times x plus 1, but then we're going to combine that to x plus 1 squared. So what that means is that when we do this, when we set up these fractions, okay, we're going to have the original 5x squared plus 20x plus 6 over our factored form. It's going to have one fraction, a over x, plus b over x plus 1, but because I have x plus 1 squared, I must also have c over x plus 1 squared. Because the least common denominator between all three of those fractions is x times x plus 1 squared. So we have to have that extra term. Now, if we had x times x plus 1 to the third power, then we'd have a fourth fraction plus d over x plus 1 to the third power. But we're going to follow the same steps. Multiply everything by the least common denominator. This does get a little bit hectic, because now what happens, the left side still will be 5x squared plus 20x plus 6. But on the other side, when I distribute this, okay, when I distribute this to the x's get canceled, so it's going to be a times x plus 1 squared plus, when we distribute it to the b, just one of the x plus 1 squareds will get canceled. So it's going to be b times x plus 1. And then when we distribute it to the c term, the x plus 1 squareds will be canceled, so it's going to be c times x. So, like I said, finding a convenient value for x in this one might be a little bit tricky. You may say, well, what about -1? Well, if you do -1, that will only give us the c term. And they say, okay, what about x equals 0? Okay, yeah, you could do x equals 0, but then we wouldn't be able to figure out what b is, because if we plug in -1, this part would be 0, which gets rid of our b. And if we plug in x equals 0, that part will be 0. So when we multiply that, it gets rid of our b. So using the convenient values is not going to be helpful in finding all of our terms. We'll only be able to find a and c, and we won't be able to find b. So what we need to do is multiply this nasty expression out. So we have a. X plus 1 squared is x squared plus 2x plus 1 plus bx squared plus bx. I multiplied like that, plus cx. Now I'm going to distribute that a. So 5x squared plus 2x, 20x plus 6 equals ax squared plus 2ax plus 1a plus bx squared plus bx plus cx. So what we need to do then is to figure out and match up our terms. So what I mean by that is that we have 5x squared. That means if we add ax squared and bx squared, that needs to equal 5x squared, meaning a plus b must equal 5. Then for 20x, we have 2ax and bx. So when I combine those, and cx, when I combine those three things, I must get 20. And then 6 and a, well, that one is easy. That one tells us right then and there that a has to be 6. So we have the three terms we're trying to figure out. We're trying to figure out the x squared term. And for the x squared term, we said 5x squared equals ax squared plus bx squared, meaning 5 has to equal a plus b. Well, we don't know what a or b are right now. Then in red, we had the x term. So 20x equals 2ax plus bx plus cx. So that means 20 must equal 2a plus b plus c. And then we have the constant term, where 6 has to equal a. Well, that tells us exactly that a is going to be 6. All right, now we're going to be treating this kind of like a puzzle. Like we may not be able to find x squared first, or maybe we won't be able to, we weren't given the constant term like we were here. So you have to look at this as a whole and see what do we know and what can I use then to figure out something else. Well, now that we know that a is equal to 6, we can substitute that in right here. So 5 equals 6 plus b. Negative 1 is equal to b. So b equals negative 1. And then we can go to the red and say, okay, 20 equals 2 times a, which is 6, plus b, which is negative 1, plus c. So 20 equals 11 plus c. Subtract 11 from both sides. C is equal to 9. So now I have my ABCs that I can substitute back into this up here in black. So our final answer is going to be 6 over x plus negative 1 over x plus 1 plus 9 over x plus 1 squared. So this process can get rather confusing. We just have to make sure we are very organized with our work so we can see where things line up. All right, last one. We have 2x squared minus 9x plus 11 over 3 times x minus 2 to the third power. Now that 3, what we're going to do is we're going to factor out that 3 in the denominator by factoring out a 1/3. So when we factor out a 1/3, that gives us 2x squared minus 9x plus 11 over x minus 2 to the third power. Now, lucky for us, the denominator is already in factored form. So then it's going to be 2x squared minus 9x plus 11 over x minus 2 to the third equals, we have a over x minus 2. And like I was saying earlier, we have to have a fraction for each power of the denominator. So we're going to have to go all the way up to c in order to get x minus 2 to the third power. Right, then we're going to multiply everything. Multiply everything by x minus 2 to the third. So the left side is going to be 2x squared minus 9x plus 11. The a term is going to be a times x minus 2 squared, because the 1 in the denominator only takes care of one of the 3 in the numerator, plus b times x minus 2 to the first power, because we have 2 in the denominator, 3 in the numerator, and then plus c, because we have the same amount in the numerator and denominator. So then we will simplify. So we have 2x squared minus 9x plus 11 equals, well, x minus 2 squared, if we use our shortcut, simplifies out or FOILs out to that, x squared minus 4x plus 4, plus bx minus 2b plus c. All right, so then 2x squared minus 9x plus 11 equals, we have ax squared minus 4ax plus 4a plus bx minus 2b plus c. Okay, so then we're going to start matching things up. So our x squared term, we have 2x squared equals ax squared. Do we have any other x squareds? No, we don't. So we can actually just solve that and say, oh, a is equal to 2. All right, now let's go over and look for the x term. So negative 9x is equal to negative 4ax plus bx. So yeah, we could solve that right now because we know what a is, but I want to write out our constant term. So then our constant, we have 11 is equal to 4a minus 2b plus c. Now in this one, we won't be able to figure out c until we know a and b, whereas the one above, we were able to figure out c right away. So negative 9x equals negative 4 times 2x plus bx. So we can get rid of the x's, so negative 9 equals negative 8 plus b. Add 8 to both sides, negative 1 is equal to b. Then over here, with our constant, 11 equals 4 times 2 minus 2 times negative 1 plus c. So 11 equals 8 plus 2 plus c. 11 equals 10 plus c. So c is equal to 1. So we have our a, b, and c's now. And at the very beginning of the problem, we factored out that 1/3. So our final answer needs to have that 1/3 factored out. And we have a value, which was 2. So 2 over x minus 2 plus b. Our b value was negative 1. Negative 1 over x minus 2 squared plus our c value, which was positive 1 over x minus 2 to the 3rd power. And that would be our final answer. So the fraction decomposition does get a little bit easier the more you do it and the better you are at matching up your like terms and creating this little table here and treating that as a puzzle. So thanks for watching the video. Make sure to like it and subscribe.